Hello viewers, welcome back to Snap's Let's Learn Academy. In previous lecture we have discussed the operating system structure. In operating system structure we have discussed the multi-programming and multitasking. Now in this lecture we will understand the operating system services. So what is mean by operating system services? So as the operating system provides an environment for the execution of the programs, so it provides all the necessary environment for executing the user programs. So operating system provides an environment for execution of the programs, and also it makes a certain services available to the programs and to the users of those programs. The specific service provided, of course, different from one operating system to another operating system, but we can identify a common classes, and these operating system services are provided for the convenience of the programmer to make the programming task easier. Now, operating system services, coming to the operating systems services, now you can see there are users. At the top you can find the users, and they may interact the computer with the help of the user interface. So user interface are GUI interface, graphical user interface, a screen interface, and command line interface. So these are the interfaces available for the user to interact with the computer system. At the bottom layer you can find the hardware, right? So IO devices, memory, CPU, so all the hardware devices are at the bottom. Now over about this hardware there is an operating system, and this operating system is responsible for providing all kinds of services to the user, but the user is interacting with the GUI or touchscreen or command line user interfaces. So these are called the user interfaces. User interact with the help of these interfaces, and the operating system provides all the necessary environment to interact the user with the computer hardware and also to execute the program. Now there are system call. So when the system call is generated, now you can see there are n number of services available by the operating system. So operating system provides all these services like program execution, IO operations, file management, communication, resource allocation, accounting, error detection, and even correction, protection, and security. So all these services are provided by the operating system. So with the help of operating system, uh, we can get services to the program and also to the user of those programs. As we just seen the definition of this, the operating system provides an environment for execution of the program and also program and to the user of those programs. So user can interact with these user interfaces so that operating system can provide all the necessary services to the user with the help of operating system services. Now in this lecture we are talking about the operating system services. So program execution, operation, IO operation, file system, communication, resource allocation, accounting, error detection, protection, and security. So these are the 8 services we are going to discuss in this lecture. Before that, now as you can see here, 9 was mentioned because 8 were in this box, and there is a user interface. That user interface is also included here, so that you will be getting 9 services from the operating system. Now you can see There are two types, or we can say two types of functions this operating system provides. One is for the user. These starting six services, 1 to 6 services, are helpful for the user, whereas remaining three, resource allocation, accounting, and protection and security, so these are the functions which is helpful for the system and its operations. So we will talk about one by one about these services, starting six related to the user, and these functions are helpful for the users. Now, the first one is the user interface. Almost all the operating system have user interfaces, like if you are using Windows, Linux, Mac, iOS, any kind of system or any kind of operating system you are using, so you will be having operating system in it. So that operating system provides you the user interface. Either that interface might be GUI or CLI or touchscreen interface. So earlier we were talking about only two kinds of interface, GUI and CLI interfaces, but nowadays there is a touch screen interface because of emerging technology, emerging mobile phones, smartphones. In all the smartphones, mobile phones, we are using touch screen devices for IO operations. So hence the touch screen interface is also there. The first one is the graphical user interface. Now, most oftenly, we use the graphical user interface to interact with the computer system. Here, we use the menus, buttons, etc. And command line interface. So, we issue the commands. So, command is kind of a line of code or a statement. It should be written in a line so that we can provide the interface, or we can get the interface from the computer. The second service what we can get from the OS is the program execution. So in the program execution, you can see there is a figure. uh, when we enter the source code is nothing but a writing a program, then compiling it, and then that compiled code is converted into object code, and thereafter that object code is executed, and then we are getting the output. So if you take a CPP program or Python or Java program, first we write the source code, right? First we write the source code, and then we compile it, and all the source code is converted into object code, and thereafter that object code is executed, and thereafter obtaining the result. So the system must be load the program into memory to run that program. It means that first we are loading this source code program into the memory, and then that program gets run. So thereafter we are compiling and converting to object code and executing that program. The program must be able to end its execution either normally or abnormally. Means before leaving the CPU, the operating system must take care of the program should either uh, leave CPU normally, means by completing all its execution and performing IO operation, it should leave normally, or abnormally means a CPU can terminate, or other program, the higher priority program, can enter the CPU, so that the current program can be abnormally uh, end its execution. This might happen in the program execution. So this is how we can get the second service of the operating system, that is program execution. So abnormally means indicating error. If any error is there, so we have to leave the CPU, we have to correct the code, Then we can again compile it, convert the object code, then we can execute it. So that is the meaning of abnormally. The third service is IO operations. As we know that every program requires a IO operation, which may involve a file or an IO device. With the help of file, we can input some value to the program and we can obtain the result, or we can perform the IO operation through the IO device and we can obtain the result. For a specific devices, special functions may be desired, such as reading from a network interface or writing to a file system. For efficiency and protection, users usually cannot control IO devices directly. The operating system which controls the IO devices, so that the user can perform all the IO operations more efficiently and effectively. And usually, user cannot control all the IO devices. So operating system which controls the IO devices, and operating system must provide all the IO devices for the users whenever the user requires it. So therefore operating system must provide a means to do IO operation. Without IO operation, you cannot, majority of time the process will not concludes its execution. So normally it will not be terminated until you perform the IO operation. The fourth service of operating system is file system manipulation. In the file system manipulation, the file system is a particular interest. Obviously, the program need to read and write the files and directories. Any program which enters the CPU requires the IO operation, and that IO operation can be performed by the device or the file. There are n number of files and directories in the computer, and all those files and directories are managed by the operating system. They also need to create, delete them by name, or you can search by giving a file name and list out all the files information. So these all tasks is performed by the operating system. Finally, some operating system including the permissions management to allow or deny to access the files directories based on the file ownership. So if you apply the password to your file or folder, those files and folders are requires the permission of the owner. Means they will deny the access, or some of the files are read only mode files. The user can open it, they can read it, but they cannot modify it because they require the file manipulation permission. So this is how this file management manipulation is also one of the service of the operating system, so that every file which we create in the computer is created by the operating system. Its service is required for creating, deleting the files, and even for searching also, and performing the list of operations of the files and directories. We need this service by the operating system. The fifth one is communication. It is a general term. Communication means one process needs to exchange any information with another process. In such circumstances, the communication service is provided by the operating system, and such communication may occur between the processes that are executing on the same computer, or between the processes that are executing on different computer system, and those computer systems are tied together by the network called local area network or any other type of network. And these computers use the shared memory. Means any computer which wants to share some information or wants to exchange some information from one computer to another computer, they may exchange the information or resources between them with the help of the network which they connected. And also they may having the two types of communications. One is shared memory communication, another one is message passing communication. Shared memory uh, communication means, for example, this is computer 1, say let's say PC 1, let's say PC 1, and this PC 1 wants to connect with this PC 5. Assume that this is the PC 5. Now what happened? Both are connected via the local area network. Now any information they wants to exchange between them, they might have a shared memory. Shared memory means the common memory is used between the P1. The P1 can use that memory, and P5, the PC5 can use the same memory, so that they can access the common register or the global variables of this shared memory, so that they can communicate with each other, right? So such communication can also happen, and this service is provided by OS. Or else there is some message passing communication. Message passing communication means, assume that this computer is a server and PC1 wants to connect with this PC8. Assume that this is PC8. I am making it as PC8. Now one wants to communicate or exchange some resources and information with PC8. Then by passing a message to the server, it can connect to PC8, and PC8 can send a message to the server, and it can get connect with PC1 or PC2 or PC5, so that in this tokenized mechanism a message can be passed, so that both these two computers can exchange the information and the resources. They may connect with each other for their processes, and they can execute the processes. So this is how this communication service is very important while communicating with the two computers and exchanging the informations and resources with each other. And these two methods we obtain in the communication services. Either the both the computers agree to share a common memory, then it is called a shared memory communication. If there is no existence of the shared memory, they may go through the message passing technology or message passing technique, so that they can communicate with each other. All right, so this is the fifth service of the operating system. Let's move to the sixth one, that is error detection. So the operating system needs to be constantly aware of the possible errors, because errors may occur in the CPU and memory hardware, such as memory errors or power failover errors, or in IO devices such as parity errors on the disk or connection failure on the network, or lack of paper in the printer and in the user program. So there is a example given here is the paper in the printer. This is very easy to understand. Let me take this example. Lack of paper in the printer. Lack of paper in the printer means, assume that you have uh, printing a file which consisting of 10 papers. When you give the print, it is printing all the 10 papers one after another. Assume that there are only 5 papers in the paper tray of the printer. It gets only 5 printing to be done. When it try to lift the sixth page, it won't get that page. So after attempting 2 or 3 times, usually 3 attempts done by the printer, thereafter it shows the error. That is the hardware error, right? So that hardware error, it may be occurred by any hardware or by memory or by CPU or by any of the IO devices. So such errors are detected by the operating system. So who will detect this? Operating system will detect this because the printer is printed 5 papers, but it is trying to lift the sixth paper which is not there. Now it is showing the error on the screen, right? So in user interface, in user mode, on output device, it will show the error. Such errors can be detected by the operating system. For each type of error, the operating system should take the appropriate action to ensure correct and consistent computing. Means, uh, continuing with the same example, assume that after getting the error by the printer, so if we fill up the tray with the paper and again we uh, give the instruction, so one more time, if we click on the try button, so again it will correct the errors and performs the action. So appropriate action is taken by the operating system, so error is corrected. Sometimes it has no choice but to halt the system. At other times, it might terminate an error causing the process and return an error code to a process for the process to detect and possibly correct the error. So debugging facility can greatly enhance the user and programmer ability to use the system so efficiently in the operating system. So we can debug the error, what causing the process to terminate or halt. So we can detect that, we can correct that, and we can use the system in a normal mode. So this can be happen in the error detection, and even though we can correct the error by using the debugging method, we can debug the error. That facility can also enhance the user and programmers abilities. Okay, so let us move to the seventh one. Now, so far, whatever the functions or the services what we have seen right now from first user interface to till the error detection, all these are useful functions or helpful functions for the users. Now, this seventh one is the resource allocation, and this resource allocation uh, this service is helpful for the system. This operating system functions exist not for helping the user but rather than for ensuring the efficient operation of the computer itself. So it resource allocation, it is for the system, not for the user. Now let us understand what is this resource allocation and how it works. Now, when there are multiple processes, now we are talking about the processes, not processors, right? So processes running at the same time, resources must be allocated to each of them. Now, when multiple processes running at the same time, resources must be allocated to each of them. Means many different types of resources are managed by operating system like CPU cycle, main memory, file storage, IO devices, etc. And to determine how best the use of the CPU and the operating system have CPU scheduling, routing, that take into account of speed of the CPU, the jobs that must be executed, and the number of registers available, and other factors also used in the resource allocation, so that there may also be routines to allocate the printer, modems, USB storage devices, other peripheral devices as a resource to the processors. Now, here the P1 is the process, P2 is the process, P3 is the process. So, three processes are running at the same time and they are looking for the resources. So, we have two resources, R1 and R2. So we have two resources, R1 and R2. So already R1 is allocated to P1 and P2 is requesting to R1 and also P3 is also requesting for R1 and R2 is allocated to P2 and it is requested by P3, right? So like this, a resource can be used by one process after its execution gets complete. This resource can be freed by the P1. It can release the resource 1 and that resource requested by P2 and P3 both are requesting for the resource 1. This resource might be allocated to P2 or P3. How it is allocated? Again, we are using the algorithm and CPU scheduling. With the help of CPU scheduling and algorithm, we assign this resource to one of the process which is running in the computer at the same time. Either we can allocate to P2 or P3. It is based on what kind of CPU scheduling algorithm we are using. If we are using first come first serve basis algorithm, FCFS, first come first serve algorithm, so which one entered first, that will get the first resource and the next process will get the next resource. If we are using shortest job first algorithm, in shortest job first algorithm we will check which process is having the lesser time of execution or the burst time, and based on the burst CPU time we allocate the resource to that process. In detail, in coming lectures, we will discuss about the resource allocation and CPU scheduling. There you will understand how these resources will be allocated for the processors. Now, just for this operating system services, you just understand that when multiple processes are running uh, in the computer at the same time, every process needs some resource and those resources are allocated by the operating system, and that is the responsibility of the operating system to allocate the resources to the processes. The next eighth service is the accounting service. So we want to keep track of which program use how much and what kind of computer resources. Just now we had talked about the resources, right? So accounting means keeping track of which program use how much and what kind of computer resources. This record keeping may be used for accounting or simply for accumulating uses statistics, means we can keeping all this record to know how much resources have been used by which process or which user, how much time it has been taken in the CPU, how much time it has been kept for idle, how much time it has waited in the waiting queue. So we can get all such informations. So user statistics may be valuable tool for system administrator who wish to reconfigure the system to improve the computing services. To improve the computing services, these statistics are needed for the system administrator, and the system administrator can know what process is taking which resource for how much time, and the system administrator can configure system accordingly, so that next time when the process enters the CPU, it might take lesser time compared to the previous one, so that the system administrator will take care of this accounting for improving the computation services of the computer system. So therefore, this service is also provided by the operating system. So this is, we are talking about the system's point of view, not from the user's point of view, and these operating system functions not helping the users, but these are helping out for efficient operation of the computer system, right? The ninth one, the last one, the protection and security. So the owner of the information stored in multi-user or network computer system may want to control the use of that information. Whenever the user or the owner of the information, multi-user or network computer system, wants to control the use of information, it should be protected. So the protection and security, both these services is the responsibility of the operating system. When several separate processors are executing concurrently, it should not be possible for one process to interfere with other or with the operating system itself. So these all protection has to be taken care by the operating system. So the protection which involves ensuring that all access to system resources is controlled by the operating system, who wants which process wants which resource is also the responsibility of sharing all the resources among the all the processes is the responsibility of the uh, operating system, and taking care of all the devices of the computer system is the protection of the operating system. So security means the security of the system from the outsider is also important. If somebody wants to access the system, uh, he is an outsider, right? So we can authenticate whether he is a authenticated user or not for using the system. So by password, we can give the access to the system resources. If the password is not correct, we won't give the system resources to be accessed by the unauthenticated person. So the security means the system security of the system from the outsider is also important. So outsider means unauthorized person cannot access any of the devices if he doesn't provide a proper password or a right password. He can't gain any access to the system resources. So these all services are very important as far as the user's perspective and the system's perspective. So all these services, 9 services, are provided by the operating system. So hope you understood all these services of the operating system. So far we have discussed all these 9 types of services of the operating system. Initial 6 services for the user's point of view, and these functions are helpful for the user interface, program execution, IO operation, file manipulation or file system manipulation, communication, and error detection. And from the operating system's point of view, for the efficient operation of the computer, we have resource allocation, accounting, and protection and security. So far in this lecture, we have discussed all these 9 services. Hope you understood this concept. Kindly like, share, and comment. Thank you for watching.